So now we're going to look at a case where we have non-repeating quadratic factors. Quadratics come in the form of ax squared plus bx plus c. Notice the bx plus c is going to add greatly to this, because if I just have x squared, that's a repeated linear. I have to have the bx plus c in order to have a quadratic. So if I have a quadratic in the denominator, I'm going to have a possible linear in the numerator. And those linears in the numerator could certainly be different. Once again, though, my p over q must be a proper fraction. In other words, the numerator must have a degree smaller than the denominator. So let's do an example. We have this situation where we have 2x squared minus x plus 4 over x times x squared plus 4. Degree on the top is 2, degree on the bottom is 3, proper fraction. I break this apart. I notice this term here is a linear and this term here is a quad. So when I have a linear as a factor, I have to have a constant over the top of it. When I have a quadratic as a factor, I have to have a linear over the top of it. Since I've already used a as a constant term, I use bx plus c as my representative linear function. I want to solve for a, b, and c, which means I'll multiply by x times x squared plus 4. This is going to give me 2x squared minus x plus 4 is equal to a times x squared plus 4 plus bx plus c multiplied by the quantity of x. Cleaning that up, I get ax squared plus 4a plus bx squared plus cx. Grouping these, I group my x squared terms and I have a plus b. I group my x terms and I just have c in this case. And I group my constant terms and I have just 4a. So in this case, I can say that 2 is equal to a plus b. I can say that negative 1 equals c. And I can say that 4 is equal to 4a. So in this case, a is going to equal 1. C is going to equal negative 1. And if a is equal to 1 and a plus b is equal to 2, that means b equals 1 as well. So now I'll go ahead and write my decomposed fraction. My a value is 1 over x. Said we had a b value of 1, so that's 1x minus 1, since c is equal to negative 1 over x squared plus 4. So our last example is where we have a repeated quadratic factor. In other words, we have possibly like x squared plus 2x plus 5 represented twice in our denominator. In that case, we have to represent the initial factor of x squared plus 2x plus 5 and its repeated factor x squared plus 2x plus 5 quantity squared in separate denominators. So I've done that in this problem. We have x squared plus x plus 2 over x squared plus 2 quantity squared. Notice, because I have the c term, this does not qualify as a repeated linear. So once again, my first quadratic term is x squared plus 2. I have a linear over the top of that. And then I have the repeated quadratic function of x squared plus 2 quantity squared. And I need a new linear over that. I've already used ax plus b, so now I use cx plus b. Multiplying both sides by this quadratic squared, I get x squared plus x plus 2 equals ax plus b multiplied by x squared plus 2 plus cx plus d. I'll have to FOIL this out now, giving me ax cubed plus 2ax plus bx squared plus 2b plus cx plus b. Let's go ahead and group everything now. Here's ax cubed. Got some squared terms. There's only one of them, that's the b. I have some x terms. In this case, I have 2a and c. And then I have constant terms of 2b and b, which is 3b for my constant terms. And that's going to be equivalent to x squared plus x plus 2. Now, in this case, I am looking for a cubed coefficient, and there are no cubes, which means since the cube only represents the coefficient of a must equal 0. b is corresponding to my coefficient in front of the x squared, so b is equal to 1. I know that 2a plus c is equal to the coefficient in front of x, so 1 is equal to 2a plus c. So in this case, since a was equal to 0, c's got to equal 1. And we know b's already equal to 1. So I'm pretty much done in this case. Whoops. Let's go back. I just noticed I made a mistake. This is cx plus d. So this is d. Sorry about this, guys. So in this case, I have 2b plus d as my constant term. So my constant term in this case is 2, and that's equal to 2b plus d. Sorry about that. I know b is equal to 1, so therefore, if b is equal to 1, d has to also equal 0. Now I can go ahead and write my decomposed fraction. I have an a value of 0, so there's no x term, just a b term of 1 over x squared plus 2. My c term is 1, so I have an x. My d term is 0 over x squared plus 2 quantity squared. So there are all 4 situations you might have of linear, repeated linear, quadratic, and repeated quadratic factors of denominators in an initial fraction which we want to decompose. Write your lesson summary, do your My Math Lab, and we'll do some examples tomorrow.